the question says that read each statement below carefully and state with reasons and examples if it is true or false. So there are 5 statements about a scalar quantity, and basically we have to say that which one of these 5 statements is true. Now the first statement says that a scalar quantity is one that is conserved in the process. So this statement means that, let us take a case of a moving particle. So it starts from position in some space coordinate. It starts from A, and after traveling it moves, it again resides to A. Now this is a whole process because the starting and initial phase are same. Now for a scalar quantity, it is asking if it is conserved or not. So let us take a scalar quantity here, that is a distance. So we know that since when it started it was at distance 0, and when it ended it must have some positive distance that it has covered. So we can't say that the scalar quantity of distance is conserved in a process. So this one is false. Now in second, we have a scalar quantity is one that can never take negative values. So this is false because scalar quantity can have negative values. For example, work is a scalar quantity and we have negative work done. So this is also false. And in C, we have scalar quantity is one that must be dimensionless. So this is utterly false statement because distance, speed, these all are scalar quantities, but they have definite dimensions. So this is false. Now fourth, we have a scalar quantity is one that does not vary from one point to another in space. So this is a false statement because let us take the case of distance again. In space coordinate, obviously the distance from a particle, let's say the origin, the distance from A to B, or distance of A from point O and distance of B from point O is different. So it does vary from one point to other in space. Now in fifth, we have a scalar quantity is one that has the same value for observer with different orientation of axes. So let us assume a case of vector and a scalar. So this is a coordinate axis and this is a vector OA and this is vector OB. If we take component of OA, vector OA on x-axis, it is going to have a value that would be different from the value of its component on vector OB. So we see that if we have changed the orientation of the base vector over which we have to take the component, its value has also changed. But this is not the case with a scalar because it has got no directional sense. That is why this statement is true, which states that a scalar quantity is one that has same value for observers with different orientation of axes. Because it has got no sense of direction, it is just a value and it remains fixed irrespective of any direction. Thank you.